the reason I want to talk about IQ, really, because really that's what I'm talking about, is because the best measure of the intellect aspect isn't a Big Five personality questionnaire, it's actually an IQ test. And so it's very, very important to understand IQ, and there's a bunch of reasons for this. And the first reason is that IQ is more powerfully predictive of long-term life success than any other phenomena that can be measured among human beings. And not only that, the statistics that were used to derive IQ tests and then used to predict future performance are exactly the same statistics that every social scientist, particularly psychologists, every social scientist uses to do all of their statistics. So you can't criticize the derivation of IQ tests on statistical grounds without criticizing every single finding in psychology that's ever been made by anyone, ever since we started to use statistics. And I would say not only that, the best statisticians that psychology has ever produced are the people who invented and promoted and developed and tested IQ tests. So there's no getting out of it by saying that there's something faulty about the statistics. So here's a list of some intercorrelations here between the various facets, or the various aspects, just so you know how tightly associated they are. So industriousness and orderliness are correlated at about 0.4. That's from conscientiousness. Volatility and emotional stability at about 0.59. Politeness and compassion at about 0.44. Assertiveness and enthusiasm at about 0.47. And openness and intelligence about 0.35. So openness and intelligence seem to be somewhat maximally differentiated as far as aspects go. So the average correlation between the big five is R equals 0.22, and the correlation between the big two is R equals 0.24. So that just gives you some idea of how much segregation and how much overlap there is between the different aspects underneath the trait level. So here, let's say you want to make an IQ test. So this is what an IQ test is. The first thing you might imagine is that you have a huge library of questions. And there'll be questions that could be formulated in language or some other symbolic manner, often. They don't have to be, but often. And then they require skill or knowledge to answer. So here's some typical questions, and you could generate multiple exemplars of questions like this. What's 2 times 68? What's the capital of Georgia? How do you define hypertrichonemia? Complete the pattern, 2, 4, 8, 16. Remember these numbers, 2, 4. Then you tell them back to me. 6, 12, 15, 14, 18, 20, 22. You tell them back to me. That's a working memory test, by the way, but working memory is basically indistinguishable from intelligence in many, many ways. So then, you know, another thing I might have you do, for example, is I might show you a pattern made out of squares and then give you some blocks and so that you could make the pattern out of the blocks, and then time you to see how long it took you, or maybe only give you a certain amount of time, and if you didn't do it, then you either pass or fail. I might show you some patterns. This is like a Raven's progressive matrices test, which is one of the tests that is the most accurate at assessing nonverbal intelligence or fluid intelligence. So I might show you 6 patterns, 6 designs, and each design changes. 8 designs. Imagine a 3 by 3 array. 3 here, 3 here, 2 here, and a question mark. And then over here I'd show you a bunch of options of patterns, and one of the patterns would complete the sequence. And usually you could calculate the sequence going down or across and diagonally as well. And that looks somewhat like a working memory test in that usually the Raven's progressive matrices patterns involve a couple of different variables, like it might be color and shape or something like that. And so in order to complete the test, you have to figure out how the color is transforming and figure out how the shape is transforming. Or maybe in a more complex Raven's matrices question, it would be color, shape, and position on the page or something like that. So you're increasing the number of dimensions that have to be attended to simultaneously in order to solve the problem. So one of the things that's quite interesting about the IQ test, it really doesn't matter what the questions are. And so imagine you have a whole pile of these questions lying around, like a universal pile, a universal library of potential questions that require abstraction to solve. And then you take a random set of 100 of those. And then you give that to 1,000 people. And then you just sum up their scores. And then you rank order them in terms of their performance. And that's IQ. It's as simple as that. Now, you could do some other things. You could correct it for the age of the participant. Now, sometimes that's useful and sometimes it's not. But you could do that, and generally, if you standardize the score and you correct it for age, then what you get is an IQ score. So actually, the total would just be an indicator of general cognitive ability. An IQ score would be the indicator of general cognitive ability corrected for age. And that's it. That's all. And so here's some of the strange properties of that set of scores. If you factor analyze the data set, you'll pull out one factor and a few little bitty factors after that, and that factor will be very, very highly correlated with the sum. So correlated at 0.9, 0.92, 0.93, like really highly correlated, far more highly correlated than most tests are, reliable. Now, another thing that's very interesting is if you take another set of 100 questions and you give them to the same 1,000 people, and then you re-rank order the people, and then you correlate the rank orders, you get what I'm saying, the correlation between the rank orders will be like 0.95. So what it means is no matter which set of 100 questions you take out of this universal library of questions, people are going to score in the same order that they scored when they did the first 100 questions. And that means that IQ is extremely reliable. Test, retest reliability. This is actually an even more stringent form of reliability, which is alternative form reliability. So that's all there is to IQ. It's very simple. If you then take that rank order, then let's say you take the same 1,000 people 20 years later and you rank order them in terms of how well they're doing at their job. You could just use income, say, as a marker. There's other markers you could use, but for the sake of simplicity, let's say income. The correlation between their original rank order and the rank order of their performance will be something around, if you had a full sample of intelligence, be something around 0.5, which is 0.5 is a staggeringly high correlation. So you'll hear that when you hear people talk about effect sizes, you'll hear them say that 0.2 is a small effect size and 0.3 is a medium effect size and 0.5 is a medium effect size, and so forth. What you find out if you look at the literature empirically is that effect sizes of 0.5, correlations of 0.5, are vanishingly rare in the social sciences. If you ever do a study with a reasonable number of people with a novel measure and you're predicting something with it, if you get a correlation of 0.5, boy, you're jumping around the room because that's only going to happen like once in your life. Unless you're measuring something that someone has already measured and you just don't know it. And so it's reasonable to point out that the correlation between IQ, say, and academic performance, or the correlation between IQ and long-term career success, the size of that correlation is bigger than the correlation between virtually two of virtually any other things that social scientists have ever discovered.